Welcome back to Deep Learning with the Wolf. Today we're going to be talking about the recent interview with Dario Amodei, the co-founder of Anthropic, which is the company behind Claude. We're going to have two very interesting guests joining us today who are going to react to some things that Dario Amodei said. So let's bring in our guests.
Hi, I'm Zachary Wolf. I'm a software engineer. I was working at Boeing up until very recently on the flight simulator for the Apache 64E attack helicopter. Unfortunately, I was part of the recent mass layoffs, but seeing what's out there, got a lot of coding experience at this point in a lot of different areas, and I apparently can fly an attack helicopter.
My name is Alexander Torres. I am a first-year graduate student at Santa Clara University studying robotics and automation. I spent a lot of my time in the university makerspace working with the 3D printers and other additive manufacturing technologies. And I also have interests in autonomous robot fabrication, and I'm hoping to do my senior thesis in that field.
Dario Amodei, the CEO and co-founder of Anthropic, the company behind Claude, he spoke at the Council of Foreign Relations, and he made a prediction. If I look at coding, programming, which is one area where AI is making the most progress, what we are finding is we are not far from the world, I think. We'll be there in 3 to 6 months, where AI is writing 90% of the code. And then in 12 months, we may be in a world where AI is writing essentially all of the code. Okay, that's the end of the quote. So Zach, let's start with you, since your background is directly in computer science, and you've worked directly with complex software at Boeing on the Apache flight simulator. What was your initial reaction to Amodei's prediction? And I know you watched the entire interview yourself, that in just 3 to 6 months, AI could be writing 90% of the code.
The AI can definitely do broad strokes of coding at this point. You ask it to do a function, you specify parameters and things it has to do. It can do the broad strokes of it, and it can certainly assist you with things like Copilot. But the idea that it could completely replace human coding within a couple months ago is very far-fetched to me.
So Alex, now you're coming at this from a different angle. As someone who works with mechanical design, prototyping, and automation, proficient in SolidWorks, MATLAB, Python, and C++. So how do you see Amodei's prediction affecting your field compared to traditional software development?
I think one of the big things that AI still needs more time to be able to replace is giving it like a vague prompt, like write a piece of software that like renders a cube or something, like telling it something very broad and not giving it, as Zach mentioned, like a specific function, like write me a function that I can use to render a vertice. I think it, just in my experience working with these generative AI tools, it does much better if you give it like a slice of a program. I need help writing this function. I've already written the pseudocode. I know what the approach we need to use is, as opposed to write it from scratch. But what I've actually done with ChatGPT is written a pseudocode using like Java syntax, then converted it to Python, which not only gave me much better results than, as mentioned before, something that's a very broad surface level prompt.
So you still have this big human component that's going to be there without basically AI being able to do 100% of the code. You're just talking about AI having a specific role in it.
Yes, I'd say so. A system like the flight simulator that I worked on, and I can't go too much into detail, but I can say it's a distributed system. You have different components made with completely different people, years apart, with very radically different objectives, and they all have to work together. And an AI is not going to understand what this system is and how it all plays together.
So within what you were allowed to talk about from the work that you did, were you already seeing AI tools being integrated into the software development process?
We didn't do nearly as much secret stuff as some of the other projects did. And even we still had to be quite cautious with what we were allowed to do. We did have AI tools, well, specifically one AI tool. We had an older instance of ChatGPT, but that had to be running locally and was always behind whatever the newest, fanciest tools were, because it needed to be vetted, it needed to be approved, it needed to be loaded. And so there's that level of, here's the new fancy stuff, and here's what we can use, and here's a whole bunch of caution that we have to take by the nature of our work.
I can see where that would be frustrating, not having access to the latest tools, but it was because of all the security considerations, which is understandable. So, Alex, I know you've been working on projects like automated robotic fabrication work cells and custom designed 3D printed solutions. So, in your mechanical design work, how are AI tools changing your approach to prototyping and design tasks?
I'll first start with what I'm currently using AI for, and then I'll get to what I might potentially, like tools I'm curious to see if they'll exist in the future. So first and foremost, one of the main things I use AI for when I'm working on the mechanical side of things is basically just as like a quick reference. For example, part of what I do is I also work as a TA for a freshman engineering class, and the final robotics project is coming up. So a lot of teams are doing more complex work, using things like motor drivers, transistors, and higher power circuitry. And I had a question about using a relay versus a transistor to act as a latch. Basically, you push a button and the button stays on. There's pre-built things you can buy that do that, but we needed to make one from scratch. So I wanted to ask, like, hey, what would be the best approach for this? And it suggested a whole bunch of different things. And then from there, I came up with my own idea of how to do it.
Okay, but these don't sound like functions that are replacing either of you in a job. So in that vein, so let's start with Zachary. Zachary, if you're honest with yourself, what percentage of your software development work, since you are currently looking for work due to the Boeing layoffs, what percentage of the secure type of work that you do or that you've done in the past could be handled by an AI assistant like Dario Amodei said?
Yeah, I'm sure they're great at C++ and C and Python and Java and JavaScript and all that jazz, because that's the most common thing. But you start working on, a system like the one I was at, which is 20, 30 years old at that point. AIs might struggle to do that because there's not a lot of, especially Ada, because that's mainly used by defense contractors since that was standardized back in the 80s. They may struggle to do that because there's not nearly as much reference material, and a lot of what has been made as reference material is classified. It can't be used as training data.
In terms of the design itself, there would have to be some sort of new AI that could achieve the engineering levels of reliability that's needed for designing parts for use. Sure, even if it works 98% of the time, that's still not good enough for a lot of applications. So I still see myself having to manually create a lot of things. Like, for example, if I wanted to make a model to prototype something, I would want to make it manually. That way I know what the constraints are. I know like all the design tricks that have gone into it. Like if I'm doing additive manufacturing on a part, what tolerances are being used, where and why. All of the holes, I can like define all that manually. I guess just having that degree of control and knowledge over what you're doing. Because I feel if you put a prompt to make, say, a part into a black box and out comes something, there's a very real chance if something is off, like if you hit that like 2%, 5%, whatever the chance of something going wrong is, there's a real chance you'll miss that, especially because like even a relatively simple part, like some kind of bracket, can still have like maybe 12, 15 different sketches and operations going on. And if one of those is wrong, you print the part, then you only realize afterwards.
Okay, so it sounds to me like both of you are saying that there's no way that the human is going to be taken out of the loop anytime soon.
Yep.
Alex, from your experience working as a teaching assistant and supporting other students with their research, what aspects of mechanical design, additive manufacturing, and physical systems do you think will be the most difficult for AI to replace?
Yeah, this is kind of interesting because a lot of what I've seen students using AI for is specifically for the coding aspects, since that's what it does really, really well. For like a lot more of like the physical design aspects, I still see most students be very hands-on, and if they need a reference for something, they'll usually go to something like a YouTube video or like some kind of like guide on a blog. I haven't seen many folks like asking generative AI for help with like physical constraints. For example, like jumping back to the robot show, lots of students are like, so one of them is about a team I really like the project they're doing. They're trying to make like a walking quadrupedal robot that's like meant to be like dog-like. And if you hover your hand over it, like the eyes flash, kind of like petting it. Rather than like asking Gen AI for the physical build, they instead asked me, and we together found a bunch of like online resources and like examples. So like, for example, there was this like little wind-up walking T-Rex that someone had posted on like Cults 3D. And we were able to use that overall design to get a reference on the mechanics. I don't think, even if I asked Gen AI and it would have said like, oh yeah, make this design, it's something that's so visual, at least to me, that I don't think I would be able to extrapolate it from text. And of course, asking AI to generate an image of something specific is questionably reliable a lot of the time.
To me, you're describing a process of sort of brainstorming and the way you're gathering ideas and working together is sort of a uniquely human process. And while AI is very good, language models are very good at brainstorming, the way you're working together with your team to bring this robot together is really this very human process of collaborating together to build a robot.
I think what this is getting at for me is, specifically for the more mechanical parts of it, I feel a lot of it is visual, and right now, generative AI is still largely text-based. Like, sure, like some can do like generation or like charts and stuff, but I suppose, actually thinking about it, I almost wonder if eventually it'll have the ability to draw vector images specifically, i.e. it's able to define more specific dimensions rather than using stable diffusion or something like that. That I could see potentially getting applications, like asking for like a cross-section of a part or like some kind of prototype engineering drawing and then modeling it yourself, as opposed to asking it for an engineering part and it generates you a very abstract image that violates, that's non-Euclidean.
I like that engineer humor. So, Zachary, so you've worked in cybersecurity, when you were at Mantech, with embedded systems then at Northrop Grumman before you were at Boeing. So in your experience across these defense industry roles, what part of software development seems most resistant to AI automation, especially when security and compliance are critical?
So I'd say it's probably a mix-up between legacy code, because that's the ancient texts and nobody fully understands what did it except for that one guy who hopefully is still at the company. And again, the level of security where, there are places where even a cell phone or any sort of device that can send and receive signals are banned. And in places like that, things like generative AI are completely off the table.
Amodei made another interesting point, and he was talking about comparative advantage. He suggested that as long as there are small pieces that human engineers do that AI isn't good at, human productivity will actually be enhanced. But he also warned that eventually all those little islands will get picked off by AI systems.
Fundamentally, one of the things I think of when I hear like, oh, AI will replace like all jobs, something like that, is AI needs to be better than human error for that to happen. And especially with applications where there's so many like standard operating procedures, that sort of thing, like standards, checks, to ensure that that error is as low as possible. AI would need to be as good at that or better to even conceive about replacing like some of these especially higher level technical jobs. And to some degree, unless there's some breakthrough in computational efficiency, I question if, even if we do come up with an AI that is capable of that kind of accuracy, if it would be so computationally heavy that it's cheaper to a company just to have a human with a weaker AI model just working together.
Theoretically, AI could completely replace humans, but the timeline on that and the particulars and what those islands even are very much up in the air. I think a lot of people have this view of like the Federation from Star Trek, the post-scarcity utopia where we've got automation to handle a lot of the little things for us and we can focus more on what we prefer to. But I feel like, we're still a long ways off from that. And there is going to be a lot of hurdles that we won't even have imagined now between us and an AI that can just figure out all the little hurdles that humans can intuitively jump over.
Final question for both of you. If Amodei is right about the pace of AI advancements, what do you see yourselves doing in 5 years?
So I think regardless of if I'm building something directly or using an AI to fabricate parts of it, I still want to be building something. And that something could be really anything. It could be some sort of system or some sort of device that's useful or a service or something that people need. Because in some ways, I want to be building something that makes the world just a little bit better.
Excellent. Alex, how about you?
To me, one of the main reasons I even became an engineer in the first place was just to solve problems. Identifying a problem, brainstorming a solution, prototyping, going back to the brainstorming stage because something didn't work or I want to improve on it, going back to prototyping, building, testing, prototype, build, test, that whole engineering design process, that loop, something I not only find very enriching, but also something I find fun. So even if there is this magical super AI that comes out and is able to like make engineering parts just from a text prompt, I still enjoy the process of it. And I think this is a similar rationale to why there will be artists still around, even with like the proliferation of AI art.
Part of my inspiration is Wallace and Gromit. They're constantly building these ramshackle inventions that aren't necessarily the greatest of ideas or the most well thought out or the most efficient, but there's like this constant joy in just building these wacky things and being like, hey, I have this crazy idea to do this.
I love that. So we've covered a lot of ground today, talking about Amodei's bold predictions and talking about where the two of you see yourselves fitting into that future. What strikes me about our conversation is that while technology is rapidly evolving, there remains a crucial human element in how we direct and apply these tools. So whether AI writes 90% of the code or 99% of the code or not nearly that much of it, it seems that understanding what to build, why to build it, remains a fundamentally human endeavor. So I want to thank Alex, who is my son, and Zachary, who is my nephew, for coming on today and bringing their technical expertise and personal perspectives to, I guess, what we could call a Wolf podcast today. So both can be found on LinkedIn. So thank you, gentlemen, both for your time today. And I really enjoyed our discussion. So thank you.
Yeah, thank you again for having me.